Our next overall goal of this video is to add a valid transaction method. This will return a true or a false value, depending on whether or not we should trust the transaction output map data, as well as its input object. We're going to place this valid transaction method as a static one in the transaction class. So let's describe a new section in the tests of transaction.test.js. And this will be called valid transaction, and it'll look like the method itself. Overall, there's going to be two cases to cover when validating a transaction. The first test case is when the transaction is valid. So let's cover that with its own describe block. And the second case is when the transaction is invalid. So that is our two opposite cases. So when the transaction is valid and when the transaction is invalid. Now there's only one situation where a transaction could be valid, and that's if none of its fields had been tampered with. However, the transaction could be valid, or rather invalid, in more than one way. The first way is that a transaction output map value is fraudulent. So let's cover this, and a transaction output map value is invalid. Another way that the transaction could be invalid is that the input signature has been faked. So let's say in the transaction, input signature is invalid. All right, cool. That covers all the situations we want to have for the valid transaction method. Now we already have enough to write our expect statement for when the transaction is valid. And in this case, we want the function to return true. So let's have an if block that says it returns true. In here, we're going to expect that if we call transaction.valid transaction in the static context, and then we pass in a transaction object, so luckily all the tests already have a transaction instance to work with. And in this case, valid transaction, it makes sense to have a transaction object as the parameter. After all, we're validating a transaction, so a pure transaction object as the input makes sense. And in this case, we're expecting this to be true. All right, nice. In the opposite case, well, these should return false. So our if blocks in both invalid cases are that the function returns false. Cool. And the expect statements will pretty much be the opposite of what we currently have in the true case. So feel free to copy and paste, but instead of true, we're going to say that these should return false. And then all we have to do is to make sure that, well, in this case, the transaction output map has been messed with. And in this case, the signature is going to be something different from what we're expecting. Now, in this case, let's mess with the transaction output map. We're going to have to access an actual recipient. So why not use the sender wallet public key, which is going to be one of the recipients in the output map, since we have that remaining balance part. Let's make it something egregious like 999,999, so 999,999 currency, which is clearly wrong. All right. And then for the input signature, instead of the regular sender wallet signature, let's change the input signature to the signature from a new wallet. So that is clearly going to be fake and fraudulent. It's going to be the result of a new wallet's sign method. And we're going to sign some fake strings, so how about data? All right, great. So that completes the core of these tests. However, before we move on to actually creating the code, let's add one more piece of this. As with our other invalidation code in the project, it'd be nice to have some error logs about what went wrong with validating the transaction. So let's create an error mock at the top of this valid transaction describe block. So at the top, we're going to have an error mock variable. Before each following test, we're going to set the error mock instance to a special jest function. So that is jest.fn. And the nice thing about this is that we can assert that this jest function was called in the context of a certain method. In this case, we want to check whether or not global console.error was called during the valid transaction code. In the cases where we want an error to be logged, or rather an error to be outputted, is when the function is invalid. So in both cases, let's update the it statement to say it returns false, and logs an error. Cool, so make sure both its statements are updated. And at the end of each test, or rather at the end of each test, we want this error mock to have been called. So we'll add an expect statement where the actual value is the error mock, and we'll expect this to have been called. And we can do the same thing for the end of the case where the transaction input signature is invalid. All right, nice. Make sure you have all of those changes. So we have the invalid case, as well as the valid case and the error mock. With that, let's go ahead and run the test in the command line. So you might already have it running in the background. And the first thing that you'll notice is that transaction.validTransaction is not a function. So we need to fix that within the transaction.js file. Let's add a static method called validTransaction. And this is going to have a transaction input. Cool. As we save this, our test should update. And then the first thing is that instead of returning a true or false value, right now it's not doing anything. By default, let's have this method return true. Cool. This should get the test case to pass where we're looking for a valid transaction. And in this case, we just need to make sure that the function returns false in the cases where the transaction valid transaction rules have been broken. So we need to invalidate a transaction when it has a fraudulent output map. First, we'll check that the overall output map total matches the amount specified by the input. And that's how we can verify whether the outputs are formatted correctly. In addition, after that, we're also going to check that the input signature is invalid, or rather that it is valid. To do this, we're going to need to destructure the input and the output map from the transaction. So let's grab the input and the output map from the transaction. However, we also need all the fields from the input. So let's destructure the address, the amount, and the signature from the input. Now, the great thing about JavaScript is that we can nest the destructuring syntax. So we can take this entire thing and place it on the first line and say that the input is going to destructure the address, amount, and signature right away. Cool. That'll give us all three of those fields as well as the output map. Now we need to check whether this input amount is equal to the total of all the values contained in this output map. To do that, we're going to build an output total value. To do this, we need to check all the values contained in the output map. And to get a total, we can use the reduce function to reduce the array to a single value. This takes a callback, and the parameters of the callback are a growing accumulated total, as well as each individual item within the array, which in this case is one output amount at a time. And the result is that we want to add the output amount to the total. Nice. This now allows us to add our check. If the amount is not equal to the output total, well, we're going to return false from this valid transaction function. As we save this should get past the error where we need to make sure that the amount is equal to the output total and that a transaction output map value has not been messed with. However, as seen, we also need to log an error, or rather output an error. So as the first line before returning false, let's console.error that there is an invalid transaction. And we'll even specify that it's from this address, so use a template string to interpolate in the address within the error message. Now, as we save this, we should have one overall isolated test, and then this is the case where the transaction input signature is invalid. Cool. Luckily, we already have a verify signature method within the project, so we can use that in order to make sure that the signature is formatted correctly. At the very top of the file, let's get the verify signature method from the util file that is located one directory back. So this is the result of requiring that util directory. Very nice. And let's also add a line now that if we find that verify signature returns false, well, we're also going to return false from the overall valid signature, or rather valid transaction method. This takes in a public key, which in this case is the destructured address, The data is the destructured output map. And then we have the signature to pass in as well. So overall, if this returns false, well, we should also return false. And not only that, we're going to console.error a message. And in this case, we're going to have something similar to the above message, but we're going to say we have an invalid signature from this address. As we save this, we should now have a fully green passing test suite as we've covered the final test case for the valid transaction method. All right, awesome. So with that, we now have a way to validate well-formed transactions and then invalidate fraudulent ones. Moving on, let's give the wallet class a direct method to now create transaction objects. This is going to be particularly useful because transaction objects are based on sender wallets. So this means that currently, in order to create a transaction, we have to separately create a wallet and then pass in a new transaction instance every time. But with the create transaction helper method in the wallet class, we can pass in the local wallet instance implicitly. Much more handy. So let's do that next.